Hello again. And again, I'm glad you're reaching out for help. The language of stats can certainly be confusing, and I don't want you to feel like, I've said you said that it's been really challenging for you and frustrating, and I don't want you to get frustrated. So yeah, it's better to certainly just ask, and this is a really easy way for us to make sure that you understand it. So for this one, it's the same sort of as the other problem we just looked at, but instead you have the t distribution rather than the normal distribution. So we use the normal distribution when we're dealing with proportion stats. So if I'm finding the confidence interval or a hypothesis test for a proportion, so like 20% is a proportion, and I also use it when I have a mean and I'm looking at a sample size that's bigger than 30. Now if I'm testing for a mean and my sample size is less than 30, I can't use my normal distribution anymore, and I have to go to what's called the t distribution. It's just a little skewed, it's a little different depending on the sample size and what we call the degrees of freedom. Okay, so here you're still dealing with alpha, and alpha is going to be the area in the tail. So if I'm doing a right tail test, that's the area in the right tail. If it's a left tail test, it's the area in the left tail. And if it's a two-tailed test, what we do is we split that area in two. And so here it says the two-tailed test is 0.01. So I'll just look at one of the tails, but I'll do it as 0.005, right? So we cut that completely in half in order to be able to get that value. Now, again, you can still go to your table, but especially when you get to more degrees of freedom, it's not as accurate as using the calculator. So again, we'll go to question help, go to StatCrunch. And then this time we're going to use the calculators as well. So you're going to go to Stat, Calculators, but instead of going to normal, go to T. Okay, so here we have our T distribution. So on that first problem, you're finding the critical value for a right-tailed test of a population mean at the alpha equals 0.05 level of significance with 20 degrees of freedom. Okay, so the first thing I'm going to do is I'm going to put that 20 degrees of freedom in there, and that's that DF. So DF is going to be 20. Now the thing about your calculator is that it only does areas to the left. Okay, now this is a right-tailed test. So remember that the whole area under the curve, even though it's a t distribution, is still 1. So if I want this is alpha equals 0.05, that means the area to the right, and the right tail is going to be 0.05, but I need the area to the left to be able to use my calculator. I also need the area to the left if I'm going to go ahead and use my table, because it does the same thing. So that area to the left, if I have to the right is 0.05, 1 minus 0.05 is going to be 0.95. So we're going to go over here and we're going to put in 0.95, and then you'll see that my z-score, it's going to be a t-score this time, is now 1.72. Okay, now on the next one here, so that would be my right-tailed test of 0.05, right? The next one here, it's a left-tailed test. So you don't have to worry about any subtraction, right? You're just going to put in, this time the sample size is 10. So just remember that the degrees of freedom is 1 minus the sample size, right? Well, or I really should say the sample size minus 1. So if n is 10, your degrees of freedom is 9. So you'll change that DF to 9. And because this is left-tailed, you can just put in 0.01 and boom, you have your t-score. Now, when it comes to a two-tailed test, again, that means that alpha equals 0.01. The area in both of the tails is 0.01. So you're going to cut that in half. So do 0.01 divided by 2 in your calculator, right? It'll get you 0.005. And that's the number that I'm going to put in for the area instead. Okay, now this would be the same thing, the whole idea of this whole subtraction, right? If I were using the table here, okay? So with this table, it's not the same as the Z table, the standard normal, because my degrees of freedom is on the left, okay? And then the area in the tail, and again, this is the area in the right tail, is on the top, okay? So if I'm going to do this in the table itself, I'm doing a right-tailed test with alpha equals 0.05 with 20 degrees of freedom. I'm going to go down to 20. And again, this is the area in the right tail. So I want to go to 0.05. And if I go to 0.05, you see I'm getting that same value that I got in my StatCrunch, the 1.725. And I would just round that off. Okay? I think they wanted us to round it. No, this is going to be 3 decimal places. Okay, so this one's 3 decimal places, and I think in StatCrunch we were getting that same number. Yeah, so we'd round to 1.725 because this is next to the 4 is a 7. Okay, so yeah, the t-distribution is a little bit different where they're using that area in the right instead of the area in the left. So you'll still have to do some division or subtraction to make sure that you're finding the area in the correct tail. And again, I would use this calculator over the table just because it is more accurate and it's a little easier to get your values.